Welcome to the ET335 VHDL and Verilog lecture. Here I have a chart showing our logic gates, Boolean, our symbol, truth table, and VHD in Verilog. So if we take a look at our AND gate, here's our AND, there is the symbol, here's our truth table. Our Boolean is going to be A times B equals X. VHDL is going to put an AND in the middle, so it's going to be A and B equals X. Verilog, which is a shorter version of HDL, it's going to use the AND symbol. Okay, so in VHDL we're going to use this. The OR gate symbol, truth table, and Boolean is going to be A plus B. And in VHDL it's going to be A or B. Or in Verilog, it's going to be A pipe B. And that pipe is a shift backslash. And our inverter or not is going to be a bar over our A for Boolean. And we're going to use not A for VHDL and an exclamation point A for Verilog. Okay, here's another chart showing our inverted gate. So here we have a NAND, and we have AB bar in Boolean. So on VHDL, we need to use not parentheses A and B and close parentheses. So we need the parentheses, otherwise it's just going to invert the A. Verilog is going to be exclamation point, A, and symbol, and B, and make sure that we use the parentheses, otherwise it will not be correct. Nor, we're going to have a bar over A plus B. VHDL, we're going to have not quantity A or B. And for Verilog, it's going to be exclamation point, quantity A, pipe B, close parentheses. Okay, here I'm showing our exclusive gate. So the first one's exclusive OR, and in Boolean it's going to be A and a plus with a circle around it, and in VHDL it's going to be A XOR or B, and in Verilog it's going to be A caret B, and for NOR gate we're going to put a bar over our exclusive OR, or we could put A X NOR B, or we could do not A XOR or B. In Verilog, we're going to use an exclamation point and quantity A caret B. And that's going to be our exclusive NOR. Here we have two logic circuits, and let's go ahead and write the Boolean, VHDL, and the Verilog equations. So our first one's going to be A plus B, and then we're going to just put a bar over it. So our Boolean is going to be A plus B bar, and our VHDL is going to be not A or B, close parentheses. And our Verilog is going to be exclamation point A pipe B. And our next one's going to be A times B bar. And this guy is just going to be a bar C. And we're adding, so we got A B bar plus C bar with a bar over it. So let's go ahead and do our VHDL. It's going to be not A and B, or not C, and let's close the parentheses. And the Verilog is going to be exclamation point, parentheses, parentheses, A and, symbol and B, pipe exclamation point, C. Close the parentheses, and we have a balanced out set of parentheses, so it looks good. All right, here we have our CAD equations, and it looks like we did very well. Here's 3 more logic circuits we could convert. So first we're going to have A plus B bar, C plus D bar, and this is going to be C plus D bar bar, and we can cancel that out. And our Boolean is going to be A plus B bar plus C plus D, no bar. And we're going to put a parentheses all the way across, and we don't need this. And our VHDL is going to be not A or B, and then it's going to be C or D parentheses. So we have balanced parentheses, and our not is going to be over the entire thing. So let's go ahead and do our Verilog. A pipe B, pipe C, pipe D, parentheses. Okay, and let's do our next one. So this is going to be A, B, C, bar. So our VHDL is going to be not A and B and C, parentheses. And so our Verilog is going to be A and B and C, parentheses. Okay, and then our last one, this guy is going to be, so we're going to add those. So we're going to have A plus A bar plus B bar plus C bar, the whole thing. So our Verilog, or excuse me, our VHDL is going to be not A or not B. We could go ahead and do this, and or not C. And these may work without the parentheses, but more parentheses the better. Let's go ahead and, as long as they're correct, of course. A or not B or not C. And that's, and let's go ahead and put parentheses all around them just to be safe. Good. Here are the CAD answers for our homework, and it looks good. Here's our last logic diagram. Let's convert it to Boolean here. So we're going to have A plus C bar, and here we're going to have B times C bar, and our Boolean is going to be A plus C bar. Let's put a parenthesis around it so we could multiply it. B, C, and we're going to put a bar all over it because of the and. And let's go ahead and do our VHDL. So we're going to have a not A or C, and not B and C, two parentheses. parentheses. Good. Now let's do our Verilog. Not, parentheses, not, parentheses, A pipe C, and not B and C, two parentheses, and we got it. Okay, here's our CAD answer, and it looks like we did good.